Good evening, class 9, unit light. Question number 1. Mention some properties or characteristics of electromagnetic waves. Not other waves, like not mechanical wave. Characteristics or features or properties of electromagnetic waves. See, some properties of electromagnetic wave are as follows. Different types of properties. Property number one, they cast shadows. See, waves. Electromagnetic waves cast shadows. Chaya parsa. Another, they obey the laws of reflection, refraction, diffraction, and interference. Returning of light, reflection, bending of light, bending of electromagnetic wave, refraction, diffraction, and interference. Four laws can be or are obeyed. They cast shadows. Another, speed. They can travel even through vacuum at the rate of, here rate means speed, at the rate of 3 into 10 to the power 8 meter per second. Their speed is very high, 3 lakh kilometer per second. And another important question is, they increase the temperature or temperatures of the molecules called or particles of the medium through which they travel or propagate. Property number one, they cast shadow. Property number two, they obey the laws of reflection, refraction, diffraction, and interference. Property number three, they can travel even through vacuum at the rate of 3 lakh kilometer per second or 30 crore meter per second. Number four, they increase the temperature of the molecules or particles of the medium through which they travel. Four properties are most important. Question number 2. Define refractive index with two examples. What do you mean a refractive index? It has, you can write in three ways. First way, second way, and third way. रिफ्लेक्टिभ इन्डेक्स भनेको के हो त? जब लाइट एक ठाउँबाट अर्को ठाउँमा जान्छ, एउटा मिडियम टु अर्को मिडियममा जान्छ, त्यहाँ लाइट बेन्ड हुन्छ, त्यस्तो बेलामा साइन आई बाई साइन आर. यु क्यान डिफाइन रिफ्रेक्टिभ इन्डेक्स इन थ्री वे. सोल्युसन. फर्स्ट वे, refractive index is the ratio of the real depth x to the apparent depth while light travels from one medium to another. When light travels from one medium to another medium, what happens? See, light is traveling from denser to a rarer medium. So it is bent away from the normal. The light ray which is coming from A, this A seems to be coming from A dash. Actually A, but the light seems to be coming from A dash. So actually, see, I draw the diagram. See, this one and this one. This is just Y. Here, this to this apparent depth, this to this real depth. It is real depth X, this is just apparent depth Y. So real depth is more than the apparent depth. तलबाट आइरहेको लाइट माथिबाट आइरहेको जस्तो लाग्छ र यो real depth, यो apparent depth. So it is the ratio of the real depth X to the apparent depth. See, from here to here X real depth, say O to A real depth, O to A dash apparent depth, and here we can say X and here Y. So X real depth apparent depth, say Y. The formula is real depth X to the apparent depth Y. It is the ratio of two depths. First definition. Another definition is also there. Sin I by sin R. Refractive index is the ratio of the velocity of light in vacuum. In vacuum or air, normal air, to that of the medium. Refractive index is the ratio of the velocity of light in vacuum, say VA, to that of the, to that means to the velocity of light in the medium concerned. See, I write refractive index means velocity of light in vacuum upon velocity of light in the medium. What is the velocity of light in the vacuum and what is the velocity of light in the medium? That ratio is called refractive index, or refractive index is denoted by mu. Velocity of light in air or vacuum is denoted by VA. Velocity of light in the medium is written as VM. You can write any other symbols also. VA means velocity of light in air. VM means velocity of light in the medium. For example, 3 into 10 to the power 8 in vacuum. For glass, 2 into 10 to the power 8. 3 by 2, 1.5. Refractive index is 1.5. For example, water, 1.33, and glass is 1.5. Two examples, or I'll write down example later on. There is another definition of refractive index, third definition, which is very important while solving the problem. refractive index is the ratio of the sine of the angle of incidence to that, or to the sine of the angle of refraction, say R. It is, refractive index is also the ratio of the sine of the angle of incidence to the sine of the angle of refraction. So you can write refractive index equal sine I upon sine R when from what? Rarer to denser medium. When light travels from rarer medium to a denser medium, the ratio of sine I to sine R is called refractive index. I'll write one example: rarer medium to denser medium. Rarer to denser medium. This is not the angle of incidence. The angle of incidence is this one. The angle of refraction is this one. The angle made by the incident ray with the normal angle of incidence, the angle made by the refracted ray with the normal angle of refraction. This is not the angle of refraction. This is not the angle of incidence. So, when the light travels from rarer to denser, the ratio of sine I to sine R equal refractive index. In this case, because I is more than R, the angle of incidence is more than the angle of refraction. When light travels from rarer to denser medium, it is bent towards the normal. Another definition: mu equal sine R upon sine I when light travels from denser to rarer medium. When light travels from a denser medium to a rarer medium, the ratio is this. Instead of going straight, it is bent away. When light travels from denser to a rarer medium, to a rarer medium, light is bent away. So the ratio of sine R by sine I equal refractive index in this case only. So refractive index can be summarized as, I'll summarize: refractive index, real depth by apparent depth. It has three formulae. Refractive index equal x by y, means real depth by apparent depth. First, another, velocity of light in the vacuum to velocity of light in medium. Sin I by sin R when light travels from rarer to denser, or sin R by sin I when light travels from denser to a rarer medium. Properties of electromagnetic wave, finished. Refractive index, example already written: water 1.33, glass 1.5. Question number 3. Draw a diagram of a glass slab to show refraction of light through it. A glass slab, draw and show incident ray, normal, refracted ray, emergent ray, angle of incidence, angle of refraction, angle of emergence and lateral displacement. But you have to know one technique. If you forget all the sentences, you remember this: R D towards, D R away. It means rarer to denser towards, denser to rarer away. This technique is very important. So, first, let me draw a glass slab. First of all, here I have to write down the index. This is a glass slab. Draw perpendicular. Incident ray, straight. Light is bent towards the normal. Here, again draw one normal. It goes straight in this way. Actually, it is the path, but it is bent away from the normal. So this distance, these two rays are parallel. Lateral displacement AO is incident ray, NO normal, I angle of incidence, R angle of refraction, B point of incidence, BC emergent ray, AD capital D, this is parallel to BC. The distance between AD and BC. AD and BC are parallel and the distance is lateral displacement. This angle is called angle of emergence. Angle made by the incident ray with the normal. Angle of incidence. Angle of refraction between refracted ray and normal. Angle of emergence. Angle between emergent ray and normal. Lateral displacement. Now, let me write down the index. Instead of writing index here, P, Q, R, S. So index P, Q, R, S glass slab. P, Q, R, S is a glass slab. AO incident ray. NO normal or perpendicular. OB refracted ray. BC emergent ray. AD is parallel to BC. These two rays are parallel to each other. D lateral displacement, also called lateral shift. Now, I angle of incidence, R angle of refraction, and E angle of emergence. How to draw? The drawing technique: draw a glass slab PQRS and one perpendicular. In this way, I draw again glass slab, perpendicular, incident ray, straight, bent towards normal, again bent away. In this way, you can draw. PQRS is a glass slab, AO is incident ray, NO normal, OB refracted ray, BC emergent ray, AD is the actual path. If there is no glass slab, AD is the real direction. But ray AO is first refracted towards the normal like OB, and OB is again refracted away from the normal as emergent ray. AO incident, OB refracted ray, BC emergent ray, D lateral displacement, the distance between two parallel lines AD and BC. I for angle of incidence, R angle of refraction. This angle and this angle are equal, alternate angles, and E is angle of emergence. Question number 3. Draw a glass slab and show refraction of light through it. See, question number 3. Well, you can easily define between glass slab and glass prism, which I will do later on. Last question for today is question number 4. Write 4 laws of refraction of light with ray diagrams. There are 4 laws of refraction of light. First law, second law, third law, and fourth law. First, let me draw solution. The 4 laws are as follows. The 4 laws of refraction of light. Number 1. See, you can write any. Not in order. You can write in any or I number. If you have to write 2 laws, only write 2 laws. This one, it means if a ray is normally incident, it is normally at 90 degree refracted without bending. यदि 90 डिग्रीमा रे आयो भने 90 डिग्रीमा सिधा जान्छ. If a ray is incident at 90 degree, it is refracted at 90 degree without bending, straight. It goes straight without bending. That is the first law. Second law, Snell's law. Snell's law. Suppose if you forget the Snell's law, you remember this. Sin I by sin R equal to. Remember this and you can make sentence yourself. See, Snell's law. I write in direct speech. The ratio, that means Snell's law states that, you can also write down, the Snell's law states that. Instead of writing in the direct speech, you can write in your own word. Like this. Snell's law states that the ratio of the sine of the angle of incidence I to that of the sine of the angle of refraction are for any 2 mediums is constant, which is called the refractive index. What does it mean? The ratio of the sine of the angle of incidence to the sine of the angle of refraction for any 2 given mediums is always constant, and that constant quantity is called mu. Here sine P by S, P1 by S1, P2 by S2, P3 by S3. Sine means P by S, perpendicular by hypotenuse. For angle of incidence, draw perpendicular and hypotenuse. For angle of refraction, draw perpendicular and hypotenuse. Find the ratio and you can easily like this. it becomes a little bit longer. See ratio R I see P by S. P by S, P by S. Find the ratio P by S, P by S. Draw another perpendicular. Again another perpendicular. Here find P1 by S1, P2 by S2. Here P3 by S3, P4 by S4. The ratio is always same. Sin I by sin R for any two given mediums is always constant. First law, incident 90 degree, refracted 90 degree. Second law, sin I by sin R equal nu. Third law and fourth law, two laws are here. The incident ray, the refracted ray. If you have to write down the law of reflection, you have to write down the incident ray, the reflected ray. But here not reflected. You have to write down refracted. The incident ray, the refracted ray, not reflected. Reflected why not? Refracted so. The refracted ray, the incident ray, the refracted ray, and the normal to the point of incidence all lie on the same plane. But you can write in also, in the same plane or on the same plane, it doesn't matter. It is two prepositions, on the same plane or in the same plane. If you have to write on the same plane, plane mathi inside. The incident ray, the normal and the reflected ray all lie in the same plane. 4 number technique to remember, denser to rarer away, dr away and rd towards. This technique is very important. dr away, rd towards. What does it mean? Denser to rarer away, rarer to denser towards. Follow this instruction and write down the sentence. dr away. First of all, let me draw. Denser medium to a rarer medium. What happens? Denser medium to a rarer medium. See, denser rarer medium. Denser rarer. Another rarer medium to denser medium. Rarer to denser. How to write down? When, first of all, dr away. When a ray passes from a denser to a rarer medium, it is bent away from the normal. dr away. dr away. When a ray passes from a denser medium to a rarer medium, it is bent away from the normal. Some students are confused. To avoid confusion, I have written this instruction, dr away, the sentence. Now rd towards. It means if a ray passes from a rarer to a denser medium, it is bent towards the normal. RD towards. First law, see. First law is, if a ray is normally incident, it is normally refracted. Second law, the ratio of the sine of the angle of incidence to the ratio of the sine of the angle of refraction for any two given mediums is constant, that is refractive index. Third law, just like law of reflection, the incident ray, the refracted ray and the normal to the point of incidence all lie in the same plane. And fourth law or last law is dr away or d towards. First let me no, denser to a rarer away, rarer to denser towards. But you can just show the reversibility of light. If light goes from A to B, it goes from B to A as well. That is called light retraces its path. Reversibility of light. उल्टो बाटोबाट यो पनि आउन सक्छ. A to B, B to A. dr away. If a ray passes from a denser medium to a rarer medium, it is bent away from the normal like this. dr away, denser to rarer away. rd towards means if a ray passes from a rarer medium to a denser medium, the refracted ray is bent towards the normal. dr away means denser to rarer away. rd towards means rarer to denser towards. This technique is very important. dr away, rd towards. dr away, rd towards. dr away, rd towards. So these instructions are very important to understand the sentence. You don't need to remember all these sentences. Just remember dr away, rd towards. dr away means denser to rarer away. rd towards, rarer to denser towards. This much for today.